Greetings, math friends. I would like to look at this composition of trigonometric functions, and I would like to solve it geometrically and also use an idea of a U substitution. As far as order of operations, you want to start from the inside of the nested intervals and work your way out. So if I say that U is the arc cosine of the square root of 3 over 2, I would be pulling that out here. So what was left is that I would have arc sine of u here. So pull this out, call it u, and then I would have this. The u here would be some angle, so the sine of some angle. And then these two are inverse operations, so they should cancel out as long as our u is properly within the domain and generates something within the domain of this. So hopefully this is defined when we find the arc cosine. The input for the arc cosine, as we define it in geometry, is a ratio of sides of a triangle. We're going to go ahead and take the cosine of both sides, so that will cancel this arc cosine. So the cosine of u canceling this, we want to look at the cosine of u equals the square root of 3 over 2. Now this may be something that you have memorized. We're going to go ahead and do some geometry to find a value to plug in for here. So drawing a right triangle. This triangle could live inside of your unit circle. This will be our u down here. This is adjacent over hypotenuse, so we're going to have square root of 3 here, and the hypotenuse is 2 here. We can use the Pythagorean theorem here to find this other side. Pythagorean theorem is usually taught as a squared plus b squared equals c squared. This is nice to remember as alphabetical order, but it actually provides some difficulty for students in remembering what values go where, because it doesn't correspond well to the triangle. We have a hypotenuse here that must be in the right position within the formula. I like to tell my students to use the a as altitude and the b as base, and then whatever's left is your hypotenuse. So in this case, our base is the square root of 3. The unknown is the a, and then 2 will be c. So we plug those values in here. A squared plus the square root of 3 squared equals 2 squared. 3 squared, square root of 3 squared, these are inverse operations. This just gives us the 3 back. So we have that a squared plus 3 equals 4. Subtract 3 on both sides and take the square root. 4 minus 3 is 1. Square root of 1 is 1. So we have that a is 1. Now, using this triangle, we can find what the sine of u is. Sine is the opposite over the hypotenuse, so we're going to have 1/2 here. So sine of u can be replaced by 1/2. If you have memorized a chart or have a unit circle to reference, you may be able to look on there and find that the arc sine of 1/2 is going to be 30 degrees if you are working in degrees. Or we can also, if we're in radians, say that this is pi sixths. So a lot of times as you are working in pre-calculus and beyond, you start to measure things in a radian measure, so your solution would likely be in radians. If you take the sine on both sides of this, we would have 1/2 equals the sine of 30 degrees, which is the expectation, and likewise the sine of pi sixths would be 1/2. hopefully the substitution process that I did make sense. We're starting here and just looking at this function by function as it's composed in here, working from the inside out, and used a little bit of a diagram here to do a geometric argument for this. This works well for these values that you find in the unit circle. If you don't have it in the unit circle, you'll probably want to use a calculator at some point. And depending on the requirements of your exercise, you may or may not be able to use a calculator. Go ahead and try this problem on the screen. Pause the video, and then once you've done your work, play the video and you should see the solution. Cheerful calculations.